In this ortho K example, we're going to try to increase the size of the treatment zone to address some issues of glare that the patient's got. The patient also has a little bit of against the rule cylinder left over after treatment, about 3/4 of a diopter. And we can see that that's most likely because it's coming from the lens. We have more cylinder in the refraction than we do on the cornea. And so we're uh, going to end up with some leftover cylinder unless we uh, turn this cornea into a with the rule cornea, which is going to be tough to do. I think what I would try first is to simply increase the demand, flatten the base curve so that instead of plano minus 75, we're closer to a plus 25 or plus 50 minus 75 and see if that gets the patient a little bit better in terms of vision. So the easiest way to increase treatment zone is simply to push the diameter of the treatment zone outward. It's a fairly low refractive error, so we can go pretty large. If it's a higher refractive error, then if you go too large, you're going to end up with a double ring, and the patient's not going to be any better off than when he or she started. But low refractive error, so I push it out. Also, this lens is centering pretty well. We're not too concerned about having too little alignment zone to stabilize the lens. Alignments or centration is already pretty good, so we can probably sacrifice a little bit of the alignment zone and get ourselves a little bit more treatment. So right now we're at 6.2 and 6.8. Let's try pushing out 3/10, so we'll go to 6.5 and 7.1. So when I do that, you'll notice that our power is going to drop. Right now we're at a plus 120. So you want to make sure when you're moving this point that only the position changes. You don't want to change the lift. 0. You want to leave the lift change at 0. In other words, the delta of 0. And then we're going to move this one out 3/10. Again, we're going to target a lift change of 0. So out here, you can see that we're after having moved the point out there, where our power dropped, our base curve is a little bit steeper than before. So we were at 1.2 before. We have to readjust this, and we also know we want to go a little bit flatter than original. Let's say we go to quarter flatter and aim for a target of plus 150. So we just need to click up here a few times. I'll speed this up a little bit. Okay, so now we have slightly wider treatment, a base curve that's a little bit flatter than before. Let's zoom in here, and it's fairly uniform. Well, we have a couple sections, so far we made all these changes in 100% mode, which means the change should have been uniform in every meridian of the lens. But especially with base curve changes, oftentimes if you're in freeform, you will not get a uniform change. So for example, this quadrant here, we're only at 1.32. So I'm going to go into 25% mode here, and I'm going to flatten this a little bit more just in this one quadrant so that it matches the rest of the meridians. This one's a little bit too flat, so I'll drop it down. So we won't be at exactly 1.5 everywhere, but we should be able to get pretty close in every meridian. Okay, and that's looking pretty good. Go back to our quad view. And then one final thing I think we can try here is going back to 100% mode. And we can see we have a little bit of clearance right underneath the center of the lens. Of course, this is a software guess, but based on your other observations, if you feel like this lens is not already fitting too flat, then what I would recommend is lifting here a little bit. So 1692 here at the pink. If we decrease it by 10, go to 1682. I feel like sometimes wave lenses can have a tendency to fit a little bit steep out at the edge. And so even if you have a very broad treatment zone, if there's too much central clearance, then you will end up with a smaller than desired treatment. And so reducing the sag out here should allow the center of the lens to drop down. So basically we want just enough clearance here in the center where we're not harming the cornea, obviously, and we're not also propping up the back of the reverse curve. We still want the lens to land well and solidly on the cornea back here. If we go too flat, then we're going to get a little bit too much clearance out here. So it's that fine balance between just enough clearance here and not too much clearance here at the edge. That'll give us the full potential in terms of size of treatment based on the optic zone diameter you put in there.